Morning, everyone.
Good evening.
I said good morning, right? Good evening, everyone.
Yeah, you did.
Yeah, I'm a bit tired today.
What's up, Mr. Ray?
How you guys doing? How you doing, Jacob?
Good, sir. Thank you.
That's good.
Hello, Mr. Ray.
Good day, William.
Yeah, I'm calm.
All right, so I'm
Mr.
just
Ray.
going to go through the list of names as the order I see. So as I write it down, I just know where I am. So good day, good evening, George.
Yeah, sorry, good evening.
How you doing? And Latavia,
Hi, sir. Good evening.
good evening. And Jacob, just getting across your name again, but good evening once again. And Veronica, good evening.
Good evening.
And Raymond, good evening to you as well.
Good evening. Is it possible I can leave an hour early? Because I had to go pick up my mom at LAX. Is that
Yeah,
fine?
that's fine. And yeah, that's a little hike there. So yeah, that's totally fine.
Thank you.
You're welcome. And thanks for letting me know.
Thank you.
All right, and good evening, Daniel C.
Good evening. How you doing, Mr. Ray?
I'm fine, thank you. Doing well, and hopefully the same to you.
Yes.
Good evening, Clemente.
How you doing, Mr. Ray?
I'm doing well, thank you very much, and hopefully you're having a great evening.
Yes.
It's good to know. And good evening, Maritza.
Good evening.
How are you doing tonight?
Fine, and yourself?
I'm doing well, thank you so much. And we have Norma. Good evening, Norma. And we have Susanna. Good evening, Susanna.
Hi,
How are you doing?
I'm good. How are you?
I'm doing well, thank you. All right, and good evening, Salvador.
Good evening, Mr. Ray.
How are you doing today?
Good, thank you. How are you doing?
Great. And hopefully everyone has a great evening going forwards as well. Good evening, Alma. All right, good evening, Maria.
Good evening.
Good evening.
Okay, yes, just got you, yeah. I know some of you guys might just be doing stuff, totally fine. And good evening again, William. Just writing your name down now. All right, good evening, Dorcas.
Good evening, Mr. Ray.
How are you doing tonight?
Good. And you?
I'm doing well, thank you so much.
You're welcome.
And good evening, Justine. Okay, so, as usual, we will have people coming in, but as they are, just to go over any of the homework, any challenges with the homework, we were doing ratios and proportions, and hopefully you got to do questions from the workbook.
I would like you to do sorry.
Oh, go ahead, sorry.
Yeah, I would like you to go over 23 and 24 for me.
In the workbook, right?
Yes, sir. That's page 21.
Page 21.
I do have a question also for number 7.
Okay, number 7 as well.
Yeah.
Okay, so number 7, and then you said 23, was it, Latavia?
23 and 24.
23 and 24, okay. All right, so let's go ahead and look at that one. Let me bring up get my pen. 23 and 24. All right. All right, where's my screen? Okay, so 23.
Yeah.
Let's see what 23 says. 23 says, well, it shows the table. It says the table shows the number of miles Leela drove each week on a full tank of gas. Leela's weekly mileage shows you each week for 5 weeks, and most of the mileage is pretty decent. Then it says, if Leela's gas tank holds 18 gallons of gasoline, how many miles per gallon did her car get during week 2? All right, so you could work this out by trying to set it up as a proportion. You could set it up just trying to use basic math as well. So let's see, which one do we want to do? All right, so we have, traditionally we just do miles per gallon,
Okay.
right? I can't share the screen, but it says in, hold on, I'm trying to get control of my pen. Okay, there we go. All right, so it says she holds 18 gallons of gasoline. How many miles per gallon? So when it says miles per gallon, what does the, excuse me, what does per mean?
One.
I'm not certain.
It could be
Okay,
one,
say that again, George.
it is one gallon per mile. Could it be like
Okay,
that?
so you're saying the answer would be 1 gallon per mile?
Yeah, could it be like that?
Okay, well, first, just to set it up, the word per just means like to divide.
Oh,
Remember
okay.
when we say, we haven't got there yet. Yeah, I haven't, sorry, I thought I mixed it up with another class. When we get to the part of percentages, we're gonna learn that word per literally means to divide. So it's the same when I say like miles per hour. And so miles per hour means that I'm dividing the miles by the hours. So when you see this word here, per, miles per gallon, literally means that I'm saying miles divided by gallons. So that's how I can set it up first, is miles per gallon. So, I mean, you technically could try to write it up in a ratio, but it's just easier just to go ahead and work that out because this one's very straightforward. So then you just need to see how many miles did you go in week 2?
Oh, okay, so that's gonna be 414.
Right, 414 miles. Let me
divided
erase this arrow. Hold
Hello,
on.
Mr. Ray.
Yes, good day, Gennaro. Let me write your name down before I forget.
Sorry I'm late, sir. I just got in.
Life happened. All right, so miles per gallon, and we have 414 miles per how many gallons? 18 gallons.
That'll be 23.
All right, and so you could go ahead and just calculate that. Once you work that out, it will give you your answer as in miles per gallon. And I just need to write down Marisol's name real fast. So you guys could try that real fast and just decide which one is the correct answer there. So what's 414 divided by 18? We could use our calculators. If you want, you can try to write it out completely.
Okay, 23 gallons, 23.
Right, so that's going to be 23 miles per gallon. You ever seen that before, MPG? So 23 miles per gallon is what her car got on week 2. And those who know about cars, sometimes it could be your tires. If your tires aren't filled up, it can lower your miles per gallon. If it's hot one day or cool, so it can affect the different things. All right, so that's how you would do that. And whenever you see the word per, then you're talking about division. Number 24 says, what is the ratio of the number of miles Leela drove during week 1 to, remember that word to is like a per statement, to the total number of miles she drove over the 5 weeks. So for that one, you could put this one straight in the calculator. So let me go and show you how you could just make it easy. First I need to find my calculator again. Okay, here we go. And reshare. Have I showed you guys how to use the calculator yet?
No, sir.
Oh, okay, yeah, sorry, I can't do that yet. I just realized I took a nap and I just threw off my mind today. So, you know, you don't get those root naps and you wake up and you feel delirious. Yeah, so
Yeah.
I was about to show you how to use the calculator, but we haven't got that far yet.
Okay.
All right, we still got to do calculations of decimals, and we did fractions, so we got to do decimals. And so next week, I believe that's when we will introduce the calculator. All right, so we're doing this by hand. So let me go ahead. So to do this one, it's week 1. You're doing the miles of week 1 to the miles of the total 5 weeks. So remember that word to is like a colon. So it's basically the miles of week 1, which was 420 miles, to Remember, the 2 can be a colon. The total amount from weeks 1 through weeks 5, which means you're going to have to add them up. So you're going to have 420 plus 414 plus 389 plus 421, and the last one, 396. So you get the total there, and I'm not sure if I could get 6 in here. Yes, I got it. All right, so you're gonna add them up. This is this is the workbook, page 21, and we're looking at number 24. So we're gonna add all those up. You could do it on the side if need to, if you need to do that.
Yeah, which is 2040.
Okay, so you've already done it, and I'm hoping that you wrote that out correctly. So we have 420 to 2040.
Yeah.
Okay, is everyone confirmed? Just to make sure. I'm not saying I don't trust you, George, but just want to make sure.
Yes, that's
Confirm.
correct.
That's correct. All right, so 2040. But now we have a ratio, right? We have a ratio of 420 to 2040. But what did we learn we have to do with ratios just the same way we deal with fractions?
Put it over each other.
Say that again?
Put it over each other.
I mean, you can, but when you look at the answer, how is the answer written?
Oh, you have to simplify it. That's it.
Right, we have to simplify it. So that means we need to find a greatest common factor between it. Or if we can't find the greatest common factor right away, what we could do is just start dividing by factors until we could get it into a more recognizable one. So if you notice here, we can cancel out the zeros, right? That's the same as dividing both sides by 10. So dividing by 10 is just the same as just, oh, I see 2 zeros. Let me just cancel them out at the end of the number. So doing that, dividing both sides by 10 can get it down to look a little bit easier. For some, they might be able to see a number that can go into both of those. If not, you can keep on dividing until you get something that's easier. So
Let's try to.
All right, so yeah, we could divide by 2. They're both even numbers.
Yeah.
So we could divide both of those by 2. 42 divided by 2 is 21.
21.
And 204 divided by 2 is
102.
102. All right, so then you might see that you can keep on dividing by trying to find something else. Now here, before you say there's nothing in common, think of factors of 21. And hopefully you could think of those in your head. There's a 3 and 7, right? 1, 3, 7, and 21. So that means you want to see, can 102 be divided by 3, 7, or 21? And I just saw something pop up.
No, I'm confused.
Confused about where we are, or?
No, about I thought it was a prime number.
21? No, 21 is not prime.
Yeah. Okay.
Yeah, because you have 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21.
Yeah, confused.
Right? So that means one of these numbers, 7, 14, or 21, might be able to go into 102 before we conclude that it's not. And when you look there at number 24, you see that 21 to 102 is not there. So that means more than likely, if we're doing everything correctly, one of those numbers can divide in there. And so we can check to see which one, 3 can go into 21 as well. So those are the factors of 21. 1, 3, 7, 14, and 21. The 1 doesn't really matter. So we could start with the smallest one and work our way up. If you're good already with your multiples, you might be able to figure it out faster. If not, then you could just try doing it the smallest up. So you could say, does 3 go into 102? 3 goes into 10.
3.
Say it, sorry?
3.
3 times, and I
Yeah,
wrote
9.
3
Yeah.
times 3 is 9. Subtract the 1, and you can hopefully see that already. 3 can go into 12 4 times.
4.
If you want, you can check to see if the rest of the numbers can, or you could go ahead and try to divide it and see what happens. Hopefully, you'll see that doing the 3 is going to be enough, because 21 divided by 3 is how much?
7.
7. And 7 is a what type of number, Veronica?
It's a prime number.
It's a prime number, right? So that means once I divide it by that 3, I'm going to have 7 and 34. And 7, you can't go down anymore, so you know that you stop. And then you go and look to see, well, is my answer there. I know I've done everything correctly. And is our answer there for number 24?
Yes.
Yes, it is. What answer would that be?
C.
C, yes, that's correct. So the answer there would be C in that case. All right, so hopefully that helps with everybody. I know constantly reviewing is the best thing that we can do. All right, and Jacob, I believe you had said number 7.
Yeah. It's just it's a little bit of a question, and it's probably, well, of course, it gave me problems, but when it came to simplifying
Right.
the fraction, I assumed because it was an improper fraction, I try to make it a mixed number. But when it comes to ratio, when it comes to, because it offers you that as one of the options for an answer.
Right. Okay. Right. So in this case, yeah, you have two improper fractions and one mixed number.
Yeah.
So A is written in improper fraction form, as well as C. But the question says, what is the main point of the question? It says, what is the what?
What is the ratio?
Ratio, right? So that's, I don't know if you remember, I said, when you're written in fraction form, you normally reduce it, and you always have to write it as an improper fraction. But for this one, it acts as you as a ratio. So they don't want it in mixed number form. They want it in ratio form. So automatically, you can cross out D.
Yeah, I don't remember you mentioning that. That's why I would continue to go. And of course, I had to go to the back of the book to check the just to make sure. And when I saw it wasn't the mixed number as an answer, I was like, well, why? Usually we would.
Right.
But
So
so I just wanted to bring it up because I didn't know what was
yeah, that's a great question because that will throw off people, and I'm glad you asked it. And when I said it, it was very brief. Like I didn't really push it, and I didn't
catch
it either. Yeah, and I would put myself there, and I'm glad this one came up because that's an opportunity. Because this one, and this is for everybody, because this one says what is the ratio, you don't have to change the improper fraction into a mixed number because you don't write ratios in mixed number form. Ratios have to be written in a comparison form. So 1 to 1 or 1 over 1, right? And 1 over 1 may be harder. 1 to 2 or 1 over 2, but it cannot be written as a mixed number. So if it's bigger, something like 5 to 2, then it's written as 5 over 2. But we do not write it as 2.5 because that's no longer in ratio format. It's equivalent, but it's not in ratio form.
Gotcha.
Great,
Yeah,
I'm glad you brought that up. Yeah.
GED will give you the opportunity for that too, to see if you really know the rules.
Yeah, they do, right?
What he asked of you.
Yeah, because it really definitely, would throw you off. Yeah, but it's not in ratio form. So I'm glad you brought that up. Just like the other one, sometimes it's stuff that you don't think about until the question appears. So I'm glad you mentioned that one. So for this one, just in case anyone's wondering, and I just need to write down Adriana real fast. And welcome, Marisol. I never got to say welcome to you. I wrote down your name and then kept going. And
Right, thank you.
yes, good to have you. And Adriana, you might be, yeah, I think you can hear me now. Welcome, Adriana.
So, Mr. Ray, so the ratio, it will be 96 over 60, and we just divide it by the greatest common factor, correct?
Right. So it's 96 miles over 60 miles because that is equivalent. That's equivalent to saying 96 miles to 60. And those are the two of the three ways that you can write a ratio. The only other way that you can write a ratio is 96 to 60. And that's how they wrote it. They said 96 miles on Monday and 60 miles on Tuesday. And then they say, what is the ratio of Monday to Tuesday? So you can either write it this way, in verbal form, 96 to 60, as a fraction, 96 to 60, or per 60, right? And then 96 to 60 using the colon. But we don't want to change it into a mixed number as was asked by Jacob. And I'm glad you brought that up because it brings it up for hopefully next time on an actual test. So yeah, we go ahead and we can continue right here, 96 over 60, and we can find the greatest common factor between the two of them. And hopefully you know your 12 times tables. and you see that this one is divisible. The greatest common factor, two of them, is going to be 12. And 96 divided by 12 is 8.
Is 5.
And 60 divided by 12 is 5. And so, yep, this is where Jacob was asking. The temptation is going to say, oh, it's a fraction and it has to be a mixed number form. And so 5 goes into 8 one time with 3 left over 5. And then you're like, wait a minute, that's C and D. Right. Which one is correct, right? And so the reason why we want to choose the 8 over 5 is because 8 over 5 is written in ratio form, as ratio is comparing two quantities, and a mixed number just does not do that.
So I'm making myself a note over here, Mr. Ray. So do not put
a ratio
on to mixed numbers when they ask you for a ratio.
Right. That's correct. When they ask it for a ratio, you do not change it into a mixed number. Only when your answer represents a pure fraction.
Yep.
So if your answer is supposed to be a fractional answer that is not comparing two quantities, then you change it into a mixed number. If they're specifically saying that this is going to represent a ratio, as you see here, you don't understand what that is, right? Like, what is that comparison? How do I compare my 96 miles to 60 miles? And so it's not in ratio form. So to get it into ratio form, you have to change that improper fraction into a mixed number. And just saying that, I can see them giving you a problem where they say there's a, I'm trying to make it up. Let's just say that two quantities share a ratio form that can be written as a fraction, as a mixed number as 1 3/5. What is the ratio, right? I can see them asking that now that I've seen this question, which would mean that you have to identify, oh, this is a mixed number. To get into a ratio form, I need to change it to an improper fraction, and then I can adequately compare the two quantities. Right? So the fact that this is here, I can see them asking it conversely. So just keep that in mind, everyone. A ratio has to be in fractional form, whether or not it's an improper fraction. We do not write ratios as mixed numbers in their final form. All right, and I've actually seen questions like these. That's why I'm bringing it up in a UK-based test. I used to teach a UK curriculum, United Kingdom curriculum, and they would do stuff like that. They would tell you that the quantity is in a proportional relationship, but they'll give it to you in a mixed number form, and you would have to know to convert it into a improper fraction to properly compare it. All right, so we have Daniel N has arrived. All right, any other questions? And I'm glad those two came up. They were good reviews. If not, we're going to move on to decimals.
One more, sir. Number 17.
Okay. Which one?
17.
Okay, number 17.
That's not a ratio.
Okay, so it says in a 30-person office, 16 people drive to work, and the rest walk or ride their bicycles. What is the ratio of people who drive to people who do not drive? Actually, this is pretty similar to that one we were doing in class, where they use that not statement of people who do to people who do not. And when you get questions like those, you're going to have to subtract. All right, so you have 30 people in all, right? That's your total. And then out of that total, how many people are driving to work?
16.
All right, so 16 drive to work. How many people do not drive to work by riding their bikes or walking?
14.
14, right? So just subtract. All you have to do is just say 30, subtract 16. It's going to give you how much are not. And so that's 14. So 16 people drive to work. And that's what the ratio is asking. It's asking, the ratio is asking how many people drive to work to those that do not. I'll just put those not. Just know it means those who do not. I just have a feeling it might mess somebody up. So those who do not drive. Right? So that's the ratio we want. So if 16 drive to work, we want to compare that to the 14 that do not drive to work. right? So that's our ratio. And so we can write it as a number without words by simply saying 16 to 14. But if we write it as 16 to 14, what do we have to do next?
Divide. Divide. By
Right? Divide by the greatest common factor. And what's the greatest common factor there?
2.
Okay, so he said 2. And if we divide both sides by 2,
6, 7.
we're going to get 16 divided by 2 is 8. And 14 divided by 2 is 7. So that is which answer?
Yeah, B.
B. All right. It's interesting. Sometimes doing the book, you start to see stuff. Notice here that in its regular form, that ratios add up to the amount of people. Normally that doesn't come up in GED, like the inverse of that. So hopefully it doesn't. Because sometimes in ratio questions, they might tell you, they give you problem solving where you have to figure out like how many are here based off of how many drive to work and the total and all that stuff. But I don't think you're gonna have to do that. I've never seen it appear, but you know, sometimes they might start to introduce it. But anyhow, any other questions?
That's
What about number 8?
Number 8. Okay, so this one says, a pancake recipe that serves 30 people calls for 12 eggs. Marty wants to make enough to serve only 10 people. What is the ratio of eggs to servings for the reduced recipe? So for this one, you could write it as a ratio, a proportion. You could also reduce it as well, just to find out, get yourself down to the amount. So here we have the original statement is, what is the ratio of eggs? So eggs is, there's 12 eggs. That's how they want you to write it. There's eggs, 2 servings. So they wrote it opposite. They wrote it opposite than, let me read it again. It says a pancake recipe that serves 30 people calls for 12 eggs. So they wrote it as the servings and then eggs, but then the question asks you to write it eggs first, then servings, if that makes sense. So that's what could throw off somebody. So they want, what is the ratio of eggs to servings?
It should be 12 over 30.
Okay, you could write it as 12 over 30.
Yeah.
I used 12
and what they want, they said, what is the ratio? Oh, actually, they just want the reduced recipe. So you don't have to even, it don't even look like they want it for 10. They just want the reduced one here. Yeah, so this one, they only want you to reduce that. So once you get 12 to 30, all they want you to do is reduce it. I didn't even know why they brought up 10. I guess it was to throw people off. So how would you reduce 12 to 30?
A.
Divide by 6. Yes, 6 is the greatest common factor. So 12 divided by 6 is 2. And 30 divided by 6 is 5. I thought they was going to ask you to compare it to 10 people, but that's all they wanted. So which answer would that be?
A.
A, right. That one would just be A.
Okay, Mr. Ray, let me ask a question. If we have to use a third place like 10 people in a proportion, how can we do it?
All right, if they wanted 10 people, then you could just times this by 2 and times that one by 2, and you're going to get 4 to 10. So you need 4 eggs.
Okay, okay.
Yeah, so that's what I thought they were going to ask, but they just wanted it in a simplified form. So if you went to see how many eggs for 10 people, it would have just been 4 eggs. You could have also set it up as a proportion by saying 2 over 5 is equal to x over 10. So just in case you went to see it. Yeah, so that's what you would have done if you was trying to solve for the missing x. You could have even wrote it as 12 over 30 equals to x over 10 and then solve for x. But you got to be careful with the GED. Sometimes they set you up and then they ask something different. So all they wanted was the reduced form of that. All right, any other questions with ratios and proportions? I'm just looking through just to see if there's anything weird. If not, then we're going to go ahead with decimals.
Mr. Ray,
Yes.
can we do 19, the last one?
Okay, and let's just do that one. Number 19 says, a recipe for a dessert calls for 2 teaspoons of chocolate and 3 teaspoons of caramel sauce. If Mary made 20 total teaspoons of dessert sauce, how many teaspoons of so you remember I was just saying, sometimes they might, in other courses, you might be asked to add stuff up. So this is a perfect example of that, where you're gonna have to add it up to see. All right, so let's see. To do this one, it's, first of all, let's write out the relationship. It says if Mary made a total of 12 total teaspoons. So first you want to see what the comparison is for the main recipe. So it's 2 teaspoons of chocolate. So I'll just put 2, chocolate, I'm gonna have to put, what's another way for chocolate? I'll put 2 CH, I'll just put cocoa. So 2 chocolate, 2 3 teaspoons of caramel. Just put car. So 3, or cara, so no one thinks it's a car. So 2 chocolate to 3 caramel. Now it says here that Mary has made a total of 20 teaspoons of dessert. So before you do anything, you want to see what is the total of your ratios when it's in its simplified state. What is the total ratio there?
5.
5. That's the total in the regular recipe state. So that means that for her, she has something cocoa when she changes the recipe to something caramel. But for hers, her blank plus her blank is equal to 20. So what is the relationship between the 5 and the 20 there? What did she do to her total recipe?
Times 4.
Times it by 4. So if she times the total by 4, then how much do we do for each element if ratios are always proportional to each other?
8 plus 12.
All right, okay, so you multiply it. 4 times 2, right? We're going to times this one by 4. 2 times 4 is 8. This one here, 3 times 4 is 12. So that means 8 plus 12 should give us 20, and that's exactly what it does. So now we can answer the question, and it says for number 19, how many teaspoons of caramel did, whatever her name is, Mary, use in her recipe? So how many did she use? So which answer then? Is it A, B, C, or D?
No, B.
Right, that would be B, 12, what is it, teaspoons? Teaspoons of caramel. Does that make sense?
Yes.
And I'm glad you asked that, because I literally, when we were doing number 17, I said sometimes questions are there where you have to add them up. And then I just dismissed it. And then bam, there you go. Number 19 actually has it. So let me just look through real quick. I just want to see if they have any other ones where they use a total. Okay, let's do number 20, because number 20 is similar to number 19.
Can I take a picture of that one?
Yes, you can go ahead.
Okay, thank you.
All right, you're welcome. Anyone else still copying? Well, if you're finished, go ahead and try number 20. Number 20 says the ratio of cars to parking spots at a local business is 2 to 3. That's the reduced ratio. If there are 24 cars, how many parking spots are there? Right, so that last part of the question tells you there's 24 cars in total, right? Oh, sorry, let me take that one back. I thought it was addition. This one says cars to parking spots. It's a little bit different. Yeah, I was looking for one that had a total. This one's a little bit different, so forgive me. That one says cars to parking spots. I thought it had said cars to cars something else. So go ahead and still try number 20. I'm just looking to see if there's any other ones that deal with a total where you have to add. looks like that was the only one.
36.
You said 36. I didn't work it out yet. Let me just do it real quick. Yes. So 36 would be that answer. That one was pretty straightforward. I could make up one regarding the ratios. So I'm actually going to use the same one, number 20. So hold on, let me just make sure that I get it to work. So yeah, for the answer for number 20, let me just make sure everybody sees that. It's 2 to 3, 2 cars to 3 parking spaces, and then they tell you it's 24 cars. If you just do it using ratios, you'll see that 12 times 2 is 24. So you just times this out by 12, just calculate there. 3 times 12 is 36 parking spaces. Or if you want to do it using proportions, you could say it's 2 to 3 is equal to X over, no, sorry.
24 over X.
Yeah, 24 over X. 24 over X, and then cross multiply, 2X is equal to 3 times 24, that's 72. And then divide both sides by 2, and X would be equal to 36. And so 36 parking spaces.
Yeah.
All right, so I'm gonna use this same question, and I'm just gonna edit it just a bit. So bear with me, I just wanna make sure I get it to work properly. And see if you guys can get it. Trying to make it that it's not too difficult, but at least challenging. All right, so let's do the same one. If we had a total, let's change it up just a bit. Actually, I'm just have to rewrite it. So I'm gonna rewrite one just to see if you guys understand it, and then I think we will be done. All right, let's say we have, let's say a parking lot. Actually, it'd be easier if I type this. Clear. So a parking lot has let's say white cars and black cars in a ratio of, I'm gonna change it, 3 to 4. If there are a total of 28 cars, how many black cars are in the parking lot? I didn't think it would do that. Oh no. What? This thing is crazy. All right. Hold on, let me just do that over. A parking lot. What I said, there are, yeah,
White and black cars.
White and black cars.
I was trying to remember how I worded it. In a parking lot, there we go. In a parking lot, there are white cars and black cars. If, what did I say?
To a ratio of 3 to 4.
The ratio of 3 to 4. Thank you. If there are a total of, did I give a total?
Yeah, 28.
Okay, that's what I was going to put again. If there are a total, there's a total of 28 cars. How many black did I say? How many black cars?
Black cars.
Yeah, how many black cars are there? All right, sorry about that. Something happened and my thing went crazy. And we could do one more just to make sure everybody's got it. Because I didn't think they would have that on there, and then bam, they did. All right.
Number 1 is 16.
Perhaps I made it up on the spot, so I have to work it out real fast. There's a total of 25. How many? Let's see. Donuts. All right, so both of these questions, I can't edit that last one, should have been a question mark there. But both of these questions are similar to number 19. So, and let me just put a question, there should have been a question mark at the end of that one. All right, so let's see. We have 16 black cars, Veronica, that's what you said, right? Was that you that came on? All right, and I've seen something else, so let's just see what it is real fast. All right, so I'm gonna let you guys know privately as you're sending me answers privately. Oh, and before I forget, welcome Daniel. When you came in, your mic was still getting processed. So Daniel N, good to have you in. All right, so remember, if you're looking for something to compare this one to, this is very similar to the one we did in number 19. And I couldn't find any other examples. It seemed like they just had that one random one there. And like I said, it was crazy because when I was working on number 17 with you guys, I mentioned that I wouldn't be surprised if they had one like that. And then bam, someone asked about 19 and there it was. So these two are similar to number 19. So if you have number 19's example there, if you compare back to number 19, it will assist you here in answering these two. Put a star next to these because this doesn't appear in the student book at all. And it only appears once in the workbook. So you would hate for it to pop up on your test and you never got accustomed to it. All right, so I'll give some steps to help with this one. You want to find the total of this ratio and compare it to the total of the actual cars. And then see if you see any relationship between the two. Once you get that, you can apply that relationship to the individual cars. Hold on, did I write that out right? Oh yeah, I did. Okay, messed me up for a second. Remember, once you apply it back to your cars, your total cars should add up to that number if you do it correctly. All right, any other answers? I have 3 answers only. So is this one a bit challenging? If it's challenging, I'll just go ahead and start it. Okay, I see the second answer, Latavia. Let me see what you put here. All right, close. There, I see 2 different answers. All right. If you got the first one correct, go ahead and try the second one. 2 of you have sent the correct answers in. And if you haven't shared your answer, if you're a bit timid, remember you can send it privately just to me if you only want me to see it. All right, so I'm not seeing any other answers and it's a bit quiet out there, so I'll go ahead and start it. What do we know about this problem here that can help us to know what to do?
There's a total of 7. I mean,
Okay.
yes, it's a total of 7. And if you divide 28 by 7 to give you 4, so you multiply 4 times 4 and then 3 times 4. And obviously 4 times 4, it'll be 16, so that'll be your answer.
There you go. That's the correct way, and others have sent that correct answer in. But yes, that's how you do it, right? You're comparing the total cars, right? No different than we've done before. We're trying to figure out what is the multiple between the ratio between 7 and 28. And so you could write it if you wanted to write it in a kind of like a ratio form. You're just simply writing it as what is the relationship from 7 to 28? You know, how do you get from 7 to 28? And what you want to do is just say 28, the total, let me write it out in words. Wait, erase the whole thing. Okay. So the total cars, let me just put total divided by actual total. So you're gonna do the actual total divided by the simplified total or reduced total. I'll put reduced total. They used that last time. Divided by the reduced total. And that's going to equal to your multiplier. Right? So your actual total, which is 28 in this case, so 28 divided by my reduced total, 3 plus 4, that's a reduced, this is the reduced ratio, 3 to 4. So I divide that by 7, and it gives me my multiplier. 28 divided by 7 is 4.
Okay.
Then you want to take your multiplier, which is the 4, and multiply it by the reduced ratio. So I'll just put here step 1, and then step 2. That sounds weird. Multiply the multiplier. Use the multiplier on the simplified ratio. That's what I write. So use the multiplier. And hopefully the word multiplier is self-evidence. It's the word is an action. So you're gonna use the identity itself on the thing. You're gonna multiply it. It's the action that you're gonna do there. So use the multiplier on the reduced ratio. Reduced ratio. And so if you use the multiplier on the if you use the multiplier on the reduced ratio, you're gonna have 3 to 4, and you're gonna multiply them both by 4. So 3 times 4 and 4 times 4. If you want it in fraction form, you have a kind of a 3 to 4, and then you're gonna multiply the top by 4, right? It's just like finding the lowest common multiple, multiplier, all synonymous, and multiply that by 4, right? So those are just 2 different ways that you could do that. And if you write it in the fraction form, you're going to get a ratio of 12 to 16. If you write it in this format, 12 to 16. And the total of your new ratio should add up to the total cars, because now you have found the actual total, the actual ratio amount. And remember, we go in a proper order, white cars to black cars, and you're looking for the black cars, so it would be the second number, so 16 cars. 16 black cars.
And when you, the way to check your work, Mr. Ray, there'll be, like you say, adding the last 2 numbers, and you have to have a total.
Right.
Asking you here, like obviously 12 plus 16 is 28, right?
Right. If it doesn't add up, you've done something wrong.
Okay.
If it adds up, and you've done everything correctly, like you know you added this first one correctly, you know you divide it correctly to get the multiplier, and then when you multiply and everything adds up, you are confident that your answer is correct.
And then the second one is pretty much the same thing.
Yeah, exactly the same thing.
Yeah, and then they also asking you for the last ratio, which is 2, which is the donut. So you're looking for the smallest ratio once you're done with your answer, right?
There you go. And I give everybody an opportunity to get that. I know for this first one, Salvador, you explained it. Veronica and Daniel C, you both sent me the correct answers there. Some of you guys, for number 2, you were getting the multiplier, and you just needed to apply it to the ratio. So you just have like one more step to do there. All right, so let me see real quick. I didn't work out the answer there. Let me just do it in my head. And yes, that's correct, Justine. And Daniel, that's correct as well for your number 2. All right, for the second one, I'm not going to write out all the steps. I'm just going to do it. And Latavia, that's correct. That's the correct ratio. But just remember, you guys always want to make sure you identify which one is the one they're looking for. Okay. And Jacob, that's correct for the final answer. All right, so what you will want to do is practice number 1 and number 19. I'm a bit distracted. I'm trying to find a worksheet on this. Number 19, and then these 2. And I'm just looking to see if I have a worksheet on this on my computer. And in about a minute, I'm going to go over the answer, unless somebody wants to explain that one as well.
Can I?
Yeah, go ahead.
So we have a ratio of 3 to 2 and a total of 25. So all I did is add the 3 and 2, that gave me a 5, divided by 25, it gave me 5. So then I times 2 times 5 will give me 10, and 3 times 5 will give me 15. They're asking for the least amount, which is the 2. So that'll be a total of 10 donuts on this plate.
All right, and the ratio, remember, is donuts to croissants, and they want donuts.
Right. So that
15 seconds.
15 donuts.
Right, 15 donuts.
Oh my God.
Oh, my bad.
Yeah, but you got it. You just got to be careful because you know GED is going to have the 15 and the 10 in there for the most questions. They have both of them there, so you got to be really careful. All right, so I just see that in my rush, I can't erase that. I'm trying to fix that 5. It looks kind of weird there. So let me just try to write over it. I can't erase it because it erases the whole font. So yeah, there you go. What Salvador said is correct. 3 plus 2, you add the ratio up, you get the total compared to the other total, the actual total. You divide them to find what the multiplier is between the reduced and the actual. Once you find out the multiplier, the same multiplier that gets you from the reduced ratio to the actual ratio will do the same thing for the actual ratio. And so you multiply the ratio, both sides of the ratio by that multiplier, and you get the actual ratio now. And then you can just make sure you choose the correct one by the order in which it's written. And donuts to croissants.
So in this case, the donuts will be the 3, and the donuts will be the 3, and the croissant will be the 2, huh?
Right. It's 3. Okay. The display, like let's say you got hired, and he's like, look, he's a real, meticulous person. He's like, I always want 3 donuts to 2 croissants. And so however many you put in there, it has to be in that ratio. And then he's like, you know what, I want 25 pastries in there. So then you're able to quickly just, say, oh, okay, well, we need 15 donuts and 10 croissants, and let me set it up to appease this guy. So yes, 3 to 2, donuts, the croissants, and that's the actual amount. All right, so we're going to call it quits there. And ratios are really, really important. And the whole unit 1, is literally the foundation of mathematics. And that's technically what this course is supposed to focus on, just unit 1. But you guys are going so fast, I think we can actually cover the majority of the course, as discussed before. So we're basically going to treat it like an HSE class and try to get through the whole thing. Oh, okay, no problem, Veronica.
I have it here. Well, I can see. Yeah.
All right, so let's go ahead, and I'm going to stop sharing, and we're going to move on to decimals. And let me just bring that up here. Now, decimals, we're going to just learn basically major operations. I had briefly gone over comparing decimal numbers, and I'm going to come back to that. I'm just...
The student book, right, Mr. Ray?
Yeah, we're back to the student, excuse me, we're back to the student book.
And what page would that be?
That is a great question, because I have it cut off here.
12? Is that 12?
12.
12? Yeah.
Yeah, I believe so,
yes. Yeah, the one before that was 11. All right, so let's go ahead. First thing we want to do is just compare decimal numbers. And let's see if I have a better screen that can help us there. Do I? And I do. All right, so I'm going to just share this screen real fast, and just to make sure everybody understands. Excuse me. All right, does everybody see the screen?
Yeah.
All right, which number is greater? So we're going to do 1B, 1C, and just see what you guys know. If everybody gets it right, that means we can move through this one pretty quickly. All right, number 1A, which number is greater?
0.365.
Okay, I hear 0.365 very assertively there. Does everyone agree?
Yes. Yeah.
Yes.
Okay, and as you see there in the question, why is it greater?
Because of the 5?
Okay, because of the 5?
Yes.
All right.
We can change it to 37, 0.37.
Okay, so you're doing rounding, yes. If you were to put it into 2 digits to compare, that would be 37 hundredths compared to 36 hundredths, which would be larger. Or if I compared it using 3 digits, I can put a 0 at the end of that 0.36, and it will look like 360 to 365, which would be larger. And remember, you can put zeros at the end of any decimal number, and it doesn't change. All right, how about the second number? Which one is the smaller number?
0.4075.
45.
75. 4075.
Okay, it sounded unanimous there. That one is correct. The 0.4075 is smaller. If you were to put a 0 at the end of that digit right there, even though it may look smaller, it throws some people off. Some people look at it as 409 and 4075, and so they say, oh, the other one's smaller because it's less digits, but it's actually this way, and so that one is actually this bigger number, and so the second one is the small number. All right, let's see if you guys can put these numbers in order from least to greatest. You can send that to me in the chat. Write the numbers in order, starting with the smallest number to the largest number. You can separate them by commas or at least by 3 or 4 spaces so that they're not jumbled up. But go ahead, put them in order from least to greatest. So the easier way to do that is to choose the smallest number, write it down, then the second number, and so forth in order from least to greatest. And hopefully everybody can get it right. You can send it to me privately or to everyone.
I'm sorry, but I don't understand it.
Oh, you're just going to write it in order. So let's say I had, let's say that somebody had, oops, let's say, let's say somebody had $10. Someone else had $8, and someone else had $15, right? If I said put them in order from least to greatest, the 8 would go first,
Yeah, the
then
10,
the 10,
the 15.
then the 15. That's in order from least to greatest. So you want to do the same thing here, is to take these numbers and put them in order from least to greatest. All right, so let's see what we've got. We've got a few answers coming in all at once. So, okay, these two are correct. So let me just let you know who is getting the correct answer by sending it back privately. Man, all right, so a lot of close answers actually. All right, so let me see if I could message everyone before all the things come in.
Oh no.
Okay, let me send my own.
Ay. Oops.
Oh, yeah.
All right, so I'm trying to write back everyone, but I had a good bit of responses here. So I doubt I'll be able to write everyone back and use up our time wisely. So let's start off with just going over the answers. One of the best ways to compare this is very similar to what I did here, in making sure all the digits have the same, all the numbers have the same amount of digits. Once you do that, that's the correct answer right there. Let me just write back, that is correct. One that just came in. All right, so let's go ahead. We want to make sure that all of our digits, all of our numbers have the same amount of digits. And so to do that, we can look at the one that has the most digits, which is this number. And how many digits after the decimal point are there? 1,
4.
2, 3, 4, right? So that means we want to have all the other ones to have 4. That makes it easier to compare the numbers and no confusion sets in. Now, some people are going to wish not to do that. But I just based off of this little exercise, you can see that it's good because I think there was a lot of answers that came in, but based off of my quick scan, I only saw one answer that was completely correct. Some of you guys just moving one number over in a spot would make it correct. Actually, 2 of them. So let me write back there. It's correct. So 2 answers were correct in that list. Just checking one more time. And it's 3. So I'm writing those people. Right now I'm just looking for those that are correct.
Mm.
4. All right, so if I skipped you, I'm sorry. Each time someone writes something, what happens is my screen resets and goes back to the bottom. So I might just skip over you once I'm writing. All right, so as you see, some of you will say, oh man, I just mixed up one number. And more than likely, you understand how to do it, but you just got to be really careful. So we want to make sure all the other digits, all the other numbers have the same amount of digits, and we could do that by just simply putting the amount of zeros. Alternatively, we can also use what's called the place value chart, and I'll see if I can share that as well. And that way you can compare the digits one by one. And so what you want to do, I don't know if I have it here. No, I don't. What you want to do is to compare. Man, what is happening? Okay, here we go. If you, sorry, when you see me scribble, I'm having trouble with the pen. So if you compare all the tenths place, you see that all the digits are the same. So that means you want to go to the next set of digits, the hundredths place. When you compare those, notice here that if you compare those ones, this one has the smallest hundredths place value. So that means 0.6 will be the first number, right? You can just cancel that out. What happened? You can just cancel that out to know that you've covered it. Then you can look at the next ones. You see here, these are both sixes. So you compare this one and you see that one's 5. 5 is less than 6 in the hundredths place. So that means this will be the second number. All right, once you do that, you can move on to the last ones. And I'm just going to clear my annotation. I'll leave it. You look at this last one, the third digit, and you notice that the third digit in the last two numbers, you have a 0 and a 1. And which one is smaller between 0 and 1? Oh, 0.
Yeah.
So that means that number is going to be the next one on our list. And then obviously, if that's third, the fourth one will be the last one there. And that's how you can compare the numbers effectively. So some of you just had like, what, maybe just, some of you might have just had like one number in the wrong position and everything else was correct. And, you know, it could be a little bit difficult just trying to look at it and write. But you just want to make sure you practice that. Sometimes you are asked to have numbers or tell which number is in the correct order, which list has them correctly. And doing that also helps you in knowing which number is the bigger number or smaller number in a list. All right, any questions on that? Like I said, if I skipped you and did not write to you saying that was correct, just let me know if I left that out. Any questions about the order of the numbers, how to put them in order? Okay, that's good to hear. And we might as well try number 2. What is the difference? What have I got here? Anyway, what is 34 hundredths of a second? How would you write that as a decimal number? Does anyone know? Veronica, that's correct. What is 34 hundredths of a second written as a decimal? If you ever listen to any sports programs, sometimes you hear the commentators speak in that fashion. They may say 5/10ths of a second. They might say 34 hundredths of a second. Examples like that. So what is 34 hundredths of a second? Daniel, C, that's correct as well. Gennaro, that's correct. You just don't need that last 0. You could drop that one off. Daniel N, that's correct as well. All right, so most of you seem to have a general understanding, so I'm just going to go ahead with time, and then I want to clarify something for somebody. That's the answer. That's 34 hundredths of a second. And what I'm going to do, I'm just going to bring up the place value chart, as I think that would greatly help. Now, we don't need the extra 0, so if you got zeros following that 4, you don't need it. When we write decimals, we normally try to write them to the nearest stated value. So it says 34 hundredths and 4 is in the hundredths place. So I'm going to stop sharing this for a while and bring up a different one. Excuse me. And hopefully this will clarify some of the issues that I'm getting in the chat. Not everyone is writing to everyone, so just bear with me. I'm just going to bring up something just to address the place values. And shouldn't take too long. I'm just trying to bring up this image of the place value chart, which I think is this one. And very similar to what I have here on the screen. Find it. All right, here we go. All right, so this is similar numbers, just a little bit different, and just trying to get back to the share screen. Here we go, share this image. All right, so slightly different. Color Fun is a different PowerPoint here. And let me just bring that up. All right, so just for those who are having some issues, I did get some messages, a few messages about trying to clarify why the list wasn't correct. And so what we can do is we're really comparing the place value, not the actual amount of numbers. Sometimes we look at the amount that's there versus the actual value. So for number one, if we were to put this in what we call a place value chart. The place value chart, we looked at the whole number part before. Now we're entering into the decimal realm. And with the decimal realm, it's literally how we say our numbers. And it really helps us when we get to writing decimal numbers as equivalent fractions. So that's the decimal part of any number. Comes after the units. So, or whole numbers, you might know the units as whole numbers. This really helps when we get to the metric measurement system. Right after the units, right? Remember, we have 100,000s, 10,000s. This is how we say our numbers: thousands, hundreds, tens. Units are the ones place. Sometimes we say ones, sometimes we say whole. So whole, ones, and units are all synonymous. Right after that, we have what's called the tens position, and then the hundreds. It does the same thing. It's like symmetric, but it ends with THS. Thousands, 10,000s, 100,000s, and it goes on for infinity, basically. So if you were to take those numbers that I just used, 37 hundredths, that's how you say it. You say the number, 37, and then you say the last digit's place value, hundredths. So that one, you read it as 37 hundredths. This number here, we read it as 365 thousandths. But the way that we compare them is by place value. We look at the position of each digit. So you notice here, in the tenths position, they're both threes. So because of that, right there, they're equivalent. But when we get to the hundredths position, that 6 is smaller than the 7. And despite the fact that it has more digits, because the 7 is larger in that position, it makes the number bigger. So one of the questions posed to me was, why was 0.661, I think, larger than 0.6587? Is because the 0.6 is larger than the 0.5, right? The hundredths place is what you're looking for. So that means that 0.37 in this question here is the larger value. It's the bigger number. And that's because I can put zeros at the end of each digit. It doesn't change it. All of these numbers represent the number 2. We would say 2 desk. Here we might say 2 seconds. Here we might say $2. And this could be used by an engineer, but they all represent the number 2. And so this is where I was saying earlier that we could simply put a 0 at the end of a digit to help us out. So putting another digit there, a 0, we can compare the numbers as 370 thousandths versus 365 thousandths. And so by putting the actual digits, you can look at them like regular numbers. 370 is larger than 365. All right, so using the place value charts can help with alleviate any confusion there. The same thing here. This is we actually use the same number, I think, for the other one. In terms of which number is smaller, you can put them into the place value chart. Many people get duped by the amount of values. They're like, oh, 4,075 is larger than 49, but that's not how you look at decimal numbers, right? You look at decimal numbers by the place value. The tenths place are the same. The hundredths place, you notice the 9 is larger. And because the 9 is larger, that means the number with more values is actually smaller. And what you want to remember is you can put additional zeros, and by doing so, you can really see the difference. And you want to look at this number. If you were to read it, this would be 4,075 10,000s compared to 4,900 10,000s. And so hopefully you can see that this one is the smaller number of the two. And hopefully that's making more sense.
Yes.
So that one would be the smaller number. And these are the same numbers that we had before. And what you can do, you can literally write them into the place value chart. You can write it as, see if I remember the number, 0.66, 0.6, 0.6587, I think it was 0.661. I think those were the numbers. And if you compare the tenths place, they're all the same. If you compare the hundredths place, though, you notice that this number is actually smaller than 0.66, right? And we can see that furthermore by putting zeros and comparing them as regular numbers. If we compare this one as 6,600, this one as 6,000, 6,587, and 6,610, it would be easier to compare the numbers. But if they're not in that format and you don't have space to write the extra zeros, remember, compare them by place value. And if you do that, you're sure to get the correct numbers. Does that help with the explanation?
Yes.
All right. I thought I sent place value charts to your group, but I could have been the other group. Did I send you guys the place value chart?
No.
No.
I don't believe so.
Yeah, so that was the other group. Let me just write down what I want to send to you guys once this class is finished. So I'm sending you guys place value charts, and I'm looking for a ratio, the total ones. And that way you can always use that to help you out with comparing numbers. All right. Okay, so the other thing we want to look at is how to use the inequality symbols, just to make sure everybody understands what that is. So remember, we are just comparing numbers, but you will be required to do so using these symbols. Do you guys know what those symbols represent?
Yeah.
Yes.
Okay,
Greater than, smaller than.
Greater than
Greater
lesser
or
than.
less than?
It's
Yeah,
greater and
I'm not sure if we did not have them in the right order, so let's say this one. How do we say the first one here?
Greater than.
Okay, I heard less than, greater than.
Less than.
Less than.
Okay, I hear less than. Okay, I'm hearing more less thans, but I did hear a few greater thans.
Greater.
Greater. Greater. Less than.
All right, so let's go over how to say these numbers correctly. The same way we treat our reading is the same way we treat math. Remember when we did integers, we count from left to right. So we start at 0 and we go up higher. So the higher up we go from left to right is the greater the number. Now we're going to use that concept here as well. We're going to read from left to right when we look at this symbol. We're going to start on the left side and work our way to the right side. We read it from left to right. Now the symbol is set up in a way that, and in mathematics, everything is associated with reality. So think of it this way. If I had a little person, let's say this was a heel. If I had a little person here, notice he would have to climb up here to get onto the top, right? It is literally like it's a giant arrow pointing to the smaller side and having a bigger side. So here it's literally pointing down, right? I was trying to think of another way to say it. Sometimes we use like a Pac-Man. We say the Pac-Man eats the bigger number. Some people use a shark. They draw a shark, eats the bigger number. Some people draw an alligator, and the alligator eats the bigger number. But the key is that you're literally, this is the smaller side, and this is the bigger side, right? And so whatever number is on the side tells you which number is the biggest. And so the way we read it is literally that. Because this is the smaller side, and this one is the bigger side, we literally read this as less than, because we read from left to right. Because the less than side is on the left side, and that's how we read it. So if we had a number here, we would say, literally, if we were to read it, 4 is less than 5. Because the less than, or the smaller side, comes first, and we read from left to right. Whereas the other one, we would say 5 is greater than 4, because 5 is greater then 4. So when we look at them as just signs, we literally read them from left to right as well. So if I was to erase the actual numbers, then I'll simply say that this means less than. Because when I read from left to right, the lesser side comes first, and I read from left to right. So that's less than, and this one is
Greater than.
greater than. Does that make sense?
Yes.
Yes.
All right, so let's apply it. We have less than and greater than. So if I was to put some numbers here, like 1.2 and 1.3, and put a line there, and then I had 0.08, and then 0.009, and 0.352, and then 0.37. What symbols would I be putting in between each of these ones? If I was to use the less than, greater than sign, remember this one is less than and this one is greater.
So 1.2 is less than 1.3.
All right, so we put it like that, right? And that's the symbol that we would put in between. That 1.2 is less than 1.3, and that's the symbol we want to use. Less than, because we're reading from left to right. The smaller side comes first. 1.2 is less than 1.3. If I was to read it backwards, I would have 1.3 is greater than 1.2. And in algebra, sometimes it's written backwards. And so that's where you really want to know how it works. All right, how about the second one? What symbol will go in between that?
Greater than.
All right, that was unanimous there. Greater than, right? And the greater side comes first. That's how we read it. So 0.08 or 800 is greater than 9,000. That's how you actually say those numbers correctly. 800s and 9,000s. And then how about this last number?
Less.
All right, that was unanimous as well. Less than, right? And it's from left to right. Okay, so that's a quick recap, hopefully for some of you, of how to compare the numbers. We also briefly went over how to say the numbers correctly and how to use the inequality symbols. So these are called inequalities.
Yeah. Look, come and look.
All right, so I'm going to mute everyone real fast. All right, so those are the inequality symbols, and you're often asked to use them in comparing different quantities. Any questions with inequalities or how to determine which decimal is larger or smaller? Okay, so we're moving on now. Okay, so we're moving on. Just a quick recap. I'll come back to it again when we get to the conversion of fractions and decimals. Just remember, if we were to read numbers, this will really help later on. So just a quick practice. How would we say this number, these numbers here? So each line that I have here, just want to see if you guys know how to say these numbers correctly. All right, does anyone know how to say that first row? How about we say that number? Your mics are muted, so if you're trying to talk, make sure you unmute your mics.
300. 300ths of a second.
Right, if it was time, yeah, we would say 300ths of a second, but we would just say 300ths. Now that word there, that's synonymous with a word when we use in money, cents, right? That word cent means 100. And so this is also 3 cents. If you had put a dollar sign there, that's 3 cents. When we're not talking about money, we drop the word cents and we replace it with hundreds. And so that number is 300s. That's correct. 300s. How about the next one? What number?
It will be
2300.
That's correct. 1 and 2300s. Some of you remember that. The decimal point represents the word and. And if you remember, some of you might, when we were dealing with whole numbers, I said do not use the word and because the and denotes the decimal point. And we saw that in the book. They actually mark you wrong if you use the word and in the whole number. The word and is how we state the whole number and the decimal part. And the decimal point is stated to be the word and. So that's 1 and 23 hundredths. Remember, the last digit is how you say the name. How about that question?
Sorry, Mr. Ray. So I've been practicing that because, you know, every time we use a number, we say 140. And
right.
Practicing that 140, not 140. Because
right, it's just 140. Yeah, 140. That's correct.
Okay.
But you're going to hear people say 140, and that normally is what throws them off in problem solving. I'm just reading a message somebody sent me. Right, that's correct, Adriana. All right, so how about the next number? How do we say that number right here? Oops,
481,000.
That's correct, 481,000. Now remember, when we get to fractions, we're going to be converting between decimals and fractions. And just for those who are pretty savvy already, 481,000 literally means 481 thousandths. So for those of you who are like, oh, that's a light bulb, go ahead with it. We will come back to that when we get to decimals, fractions, and percentages. All right, how about this last row? What is that number?
2 and 203,000.
203,000. And just to show you, as a mixed number, that's 2 and is a plus sign, 203 thousandths. And so this is how we literally get a mixed number. And like I said, we're going to come back to that. But that's 2 and 203 thousandths. That's what a mixed number is. That's what the decimals are. And we're actually going to use that to convert between decimals, fractions, percentages, and ratios. We're going to actually use the naming of the decimal numbers to help us. All right, let's go ahead and just finish off today with the addition and subtraction. Very simple process. We should breeze through this as long as you remember how to add whole numbers. Adding decimal numbers is not a problem. Actually, I have a PowerPoint on that, so let me just do that. It'll be faster for us all. We don't have to make up stuff. I believe that's it. Yep, that's it right here. And you guys see my screen?
Yes.
Yes.
All right, so adding, subtracting decimal numbers, pretty straightforward. Just trying to go to this from current slide. No. From current slide, where is it? Okay, here we go. All right, so to add the numbers, all you need to do to add decimal numbers is to make sure that your decimal points are lined up. Most people who have problems adding decimal numbers by hand do so because they try to do it like regular numbers. If you add it up like this, you will get it wrong. What you need to do is to simply make sure your decimal points are aligned and the place values are aligned. Once you do that, you just add it up like regular numbers, like they're whole numbers. All right, so whenever you're given a set of numbers, if they're not written in vertical form, you need to put it in vertical form if you're doing it by hand. And you can put a 0 placeholder if needed. So just put a 0 there so you can line it up. And then just add, right? 2 plus 0 is 2. 7 plus 5, remember that's 12, carry the 1. 3 plus 3 is 6, plus a 1 is 7. 4 plus 2 is 6. Align your decimal point and done. That's how you add decimal numbers. Right, and most of you had the answer up before I did. And that's adding decimal numbers. Simply make sure you line up the decimal point. Most problems that arise in adding and subtracting decimal numbers are that people forget to line up their place values. If you're doing it by calculator, of course, it doesn't matter, but doing it by hand, that's a really important rule. Is anyone writing down these steps? Hopefully you can just take a picture of that. It'll be faster.
Okay.
If you know how to do a screenshot on your computer, you can push print screen and it saves it. If you're on a tablet, if you're on an iPad, if you push the menu button and the power button, it takes a picture. If you're on a Android, I believe Androids, you push the power button and the volume button, the lower volume, and it takes a screenshot as well. On your computer, you should see PRTSC, and that takes a print screen. Or you can just take a picture with your camera. All right, is anyone still copying or taking pictures or anything?
No.
All right, I'm moving on. All right, let's just try these real quick. See if you can add these decimal numbers up, making sure that you line up your decimals. Just send your answers in as you get them. Remember, no calculators. We want to master doing arithmetic without a calculator, as you will be asked to do some calculations without one.
Do we send in our answers?
Yeah, you can send it in the chat. I see I have an answer already for one, or for all three from one person rather. Okay, so yeah, so far 2 answers, both correct. Veronica, Justine, well done. All right, so let's go ahead and just start it. I'm pretty sure most of you have possibly finished the first one. Remember, make sure your decimal points are aligned. This one is pretty easy to do because you have the same amount of digits. So it just automatically aligns for you. Once you do that, 0 plus 4 is 4, 4 plus 0 is 4, 3 plus 0 is 3, and bring down the decimal point. And as long as it's aligned, you got it correct. Norma, I got your first two. Yeah, that's correct for your first two. And Daniel C, yep, there we go. Adriana, correct. Second one, be careful of doing that. That's a common mistake. People line them up the wrong way. Just make sure you line them up. Whole number with whole number, decimal points together, tens, hundreds, thousands. You could put in 0 placeholders to help you, and then just add like whole numbers. 0 plus 3, add those up. 4 plus 8 is 12, carry the 1. Add those up, you get 5. Add those up, you get 12. Bring down the decimal point. And the last, I'm not sure if anyone needs that. It's going fast. But 12 and 523 thousandths is that final answer.
I had a question.
Yes.
For number 1, does it matter the order that we write it in?
You mean like 0.04 plus 3.40, like that?
Yeah, yeah, because that's how I wrote it. Oh,
Addition is what we call associative. It doesn't matter what order it's in.
Okay.
Yeah. All right, and moving on. Hopefully no one's copying. Most of you got this correct, right? Make sure that your points are always lined up. Once again, that is the most common mistake that somebody will make. And then once you do that, you add them like whole numbers. All right, and so that's how we do addition. And subtraction has the same rules. Make sure they are lined up. We just practice a few of those on subtraction. I'm not going to go over the rules, as the rules are the exact same. Make sure that your decimal points are aligned, the place values are aligned, and then subtract it just like we did with whole numbers. All right, so for that, let's try the following problems here, just to make sure everybody remembers how to subtract. Remember, same rules. Make sure your decimal points are aligned. Make sure the place values are aligned. And you can send your answers into the chat.
For subtraction, does the order matter?
Yes, I'm glad you asked that. Order does matter here. If you put in a different order, you can end up with negative numbers. And depending on the question, they might show you both the negative and whole number. So yes, order matters for subtraction and order matters for division. So we have 4 operations. For addition and multiplication, order does not matter. For subtraction and division, the order does matter. So thank you for asking that. Okay, William, that's correct. The answer she sent in. Well done there.
I don't know if this is right.
All right, Adriano, that's correct. Those answers. Daniel C, that's correct as well. And Salvador, those are correct. And that's correct for the first one, Gennaro. And
Right.
oh, that's, hold on. Check the last one. Norma, all right, so let's go ahead and start this. Just a few little arrows there that I'm seeing. More than likely, it's just the borrowing. So just be careful when you borrow. All right, so let's start going over the answers here. Remember, you want to make sure that they're lined up. A lot of times mistakes come because we line them up like we do when we multiply numbers, or even with whole numbers, because with whole numbers, you don't have to worry about lining anything up. So make sure that your numbers are lined up, or else you can get thrown off on your answer. Once your numbers are lined up, if you put a 0 placeholder there, it can really make sure that you don't mess it up. And remember, putting a 0 placeholder doesn't change the value. And just got another answer in. 1 digit is off. All right, so yeah, so we go ahead and we just add that first column. 5 plus 0 is 5. 0 plus 2. Oh, we're subtracting. What am I talking about? 5 subtract 0 is 5. To subtract 2 from 0, we're going to have to borrow from 7. So when we borrow from the 7, we get 6. And we carry that over to the 0. Remember that. And then we can subtract the 2 from the 10. All right, there you go. That's correct now. All right, so we subtract 10, subtract 2 is 8. And then we move on. You can bring the decimal down first if you want. I have it, you're welcome. I have it as the second step. So 6 subtract 4 is 2, and 3 subtract 1 is 2, and then align the decimal point. Most of you guys got the first one correct. It was the last 2. And part of the reason with the last 2, we had zeros in there. And also, number 3 has a little tricky part with the tens place that always messes people up. All right, so 1 and 7/10, subtract 1 and 45 thousandths. Remember to line them up. Make sure you have the zeros there. It makes it much easier to not make that mistake. Here, very similar to whole numbers, we're going to have to borrow twice because you cannot subtract from the 0. But when you borrow, you want to make sure you cancel. Some of you are forgetting to cancel the last, your digit once you borrow. So you can subtract the 5 from 0, and you can't borrow from the 0, so you borrow from the 7. It leaves you with 6. And that's correct, Maritza. All right, so you borrow over to the 10, carry over to the 10, and now you borrow from that 10 so that you can start the subtraction. So you borrow from the 10, it leaves you with 9. If that carries over to the 0, and now you can start subtracting. 10 subtract 5 is 5. 9 subtract 4 is also 5. 6 subtract 0 is 6. And 1 subtract 1 cancels out
Zero.
to 0. And then just align your decimal point. So you have 655 thousandths. Okay, so just make sure you see where you might have made the mistake. Make a note so that you don't do that again. I'm just writing down. I might just have to send this decimal subtraction worksheet. Okay, and then number 3, same thing. Make sure you. I'm not sure anyone's copying. Hopefully you have that. Number 3, again, make sure your decimal points are aligned. Your place values. Put a 0 there to assist you so you don't forget. When we don't have the zeros, that's when you make a mistake and sometimes do that, right? Because adding whole numbers, subtracting whole numbers, all of that doesn't matter. But once you get to decimals, it really does. And so line them up. And then remember subtraction, you can't subtract from 0, so you borrow. And when you borrow, make sure you cancel. And then you leave the 5, you carry over the borrowed 1. That makes it 10, not 1. And so we have 10 subtract 4 is 6. And then 5 subtract 2 is 3. We can't subtract 9 from 8, so you're going to have to borrow again, and you borrow from the 2. Leaves the 1 there. And then you carry that 1 over to the 8. Remember that 8 becomes not 9, becomes 18. 18 subtract 9 is 9. And then here, this is where most people get tripped up a bit. You can either treat this as 11 subtract 9, which I always think is the easiest way to tackle that, because some of the questions that were wrong were right here. You can treat this as 11. That makes it easier than trying to borrow from the 1 again and carry. That's where a lot of people get thrown off. So if you just say 11 subtract 9 right there, because there's nothing else you need to do, 11 subtract 9 gives you 2, and bring down the decimal point. And that's how you get to 2 and 936 thousandths. I had a lot of answers that were 2 and 944 hundredths. So a lot of people are getting 4 and 4 there, forgetting to borrow for that 0. And so you said 0 subtract 4 was 4, and 6 subtract 2 was 4, and then you started to carry. So be careful there. That was a very famous answer. A lot of answers I got was 2.944. It's 2.936. Any questions with the subtraction?
Nope.
I see that one was a little bit more issues there, but there are no questions. Just remember to practice lining up the decimals. All right, I really wanted to get to the multiplication before tonight was done. I was hoping division as well, but let's go ahead and move on to multiplication. Just remember with this rule to line up your decimal point. That's all you have to do. Line them up and then follow the rules of regular addition and subtraction. All right, so multiplication is, you just got to be careful with the multiplying. So let's go over. Remember, the rules to multiplication are the exact same as with whole numbers. We just add 2 more things to it, and I'm going to bring that up. So multiplying decimals, and I haven't shared the screen, have I? All right, so we're multiplying decimal numbers. I hate when that happens. Multiplying decimal numbers without a calculator. And often you will have to do that. And so 2 simple steps to multiply decimal numbers. Do it the same way you would with whole numbers. Act like there's no decimal points, no zeros. Just ignore it, act like it's not there. So we have this number here, 5 and 61 hundredths times 3 and 8 tenths. You don't have to line up the decimal points for multiplication, only with addition and subtraction. With multiplication, you're going to multiply them like regular numbers. So that means you're going to act like, you're going to still keep the decimal point there, but you're going to act like it's 561 times 38 and just multiply it the same way. So remember, you start with the ones digit and you multiply the ones digit by everything on the top. So 8 times 1 is 8, 8 times 6 is 48, carry the 4, 8 times 5 is 40, plus the 4 is 44. Remember, when we get to the second row, what do we need to put there?
0.
0 to represent you're in the tens place, right? Don't forget that step. Very common mistake there is to forget that 0. You're in the tens place. If you had hundreds, you put 2 zeros. If you're in the thousands, 3 zeros, and so forth, right? So we take that 3 and we multiply everything. 3 times 1 is 3. 3 times 6 is 18. Carry the 1. 3 times 5 is 15. Plus that additional 1 is what gives us the 16. Then we add them up just like we regularly would. And we get 8 plus 0 is 8. 8 plus 3 is 11. Carry the 1. 5 plus 8 is 13. Carry the 1. 5 plus 6 is 21. Carry the 2. 11. Carry the 1. And then 1 plus 1 is 2. Now this is where the second step comes in. With whole numbers and decimals, it's normally pretty easy to guess where the decimal point is. The problem comes when you multiply numbers less than 1. So this rule hopefully will help you. You could just use your common sense here and use your rounding knowledge that if I have about 5 and 61/100ths, that's about 6. And 3 and 8/10ths, that's about 4. And 6 times 4 is 24. And you can kind of guess where the decimal point should go. But like I said, you're going to possibly have to multiply numbers like 0.38 times 0.0015. And that's where it gets difficult. So there's a nice little rule for that. And it's simply this: the sum of the decimal places being multiplied. And remember, decimal places simply means how many digits are after the decimal point. So the sum of the decimal places being multiplied, and the sum means to add, will determine how many decimal places are in your final answer. And so there are 2 decimal place values in the first number, 6 and 1. Remember, it just means how many digits after the decimal point, and 1 decimal place in the second number. The sum means to add, so that means there'll be a total of 3 decimal place values in your final answer, or 3 digits after the decimal point. So where would the decimal point have to go in order for you to have 3 digits after that?
Between the 1 and the 3?
Right?
Between the 1 and the 3.
So
Yes.
Mr. Ray, I think we start from the right to left, or do we start from left to right?
Left to right.
You start where the decimal point would be, and the decimal point would be right there. So you start from the right and you go to the left. So you can count it as well. If it's a bit of a challenge, just count and say 1, 2, 3. You need to do 3 movements, 3 place values, 3 decimal place values you're moving, and that's where your answer would be, 21 and 318 thousandths. So no matter what the number, you can multiply it very quickly and to simply determine where your decimal points are. All right, hopefully that makes sense. Let's try about one more or so, and hope we can get this done. Okay, so I just want to show you the relationship real fast. Here's an example of just whole numbers being multiplied. If you were to multiply those whole numbers, this is what we will get, right? Just, most of you guys are pretty aware of it. What I want you to see is what happens if I put decimal points in there. So notice with the stars, there's a slight change. So I have 245 times 2. Now it's 2.45 times 0.2. For number 3, it was 148 times 32. Now it's 1.48 times 3.2. For number 4, 5,864 times 7. I'm changing that to 5.864 times 0.07. Now, what we learned from the first 2 steps is that our digits will be the exact same. The only difference will be where the decimal point is located. So can you guys find out where the decimal point should be for number 2? Where should the decimal point be located now for number 2?
Before the 4.
In front of the 4.
Right? And that's because I have 2 decimal places here, 1 decimal place there. So 3 in all. And it's only 3 digits. So that means it's 1, 2, 3 right in front of that 4. Does that make sense?
Yes.
How about number 3? Where should the decimal point be in the new answer?
In front of the 7.
All right, that was unanimous before the 7, right? 2 decimal places there, 1 here, so 3 altogether. 1, 2, 3. And so that's 4 and 736 thousandths. You can always check this with a calculator and see that that's correct. How about the last one? Where should the decimal point go?
Before the 4.
Okay, Before the 4 is what I'm hearing. 3 decimal place values are there. 2 decimal places is there. 5 altogether. 3 plus 2 is 5. And there are only 5 digits. So that means the decimal point has to be in front of the first digit. So you can also count it. Remember, the decimal point is after the whole number or the ones place. So 1, 2, 3, 4, 5, and that's the answer. All right, so if you get any trickery type questions, you can always remember that. That's the relationship. And we use that. We're going to come back to this in algebra. Actually, I always teach it in Unit 2. So we're going to learn in Unit 2 about scientific notation. It's used if you're taking the science test. This concept is really used a lot under physics and chemistry. And that's all under the science test as well. So understanding this concept really helps you later on. Let's just close out with, we're going to skip that. I just want you to see how easy you can multiply numbers. And then next week, we'll pick up with division. Just want you to see how fast you can multiply numbers once you know the digits and that trick. Remember, number 1, multiply the numbers as if you don't see the 0 or the decimal point. So what would be 3 times 4?
12.
12.
Well, notice that there's 1 decimal place there, 1 decimal place here. How many in all?
2.
2. So where would the decimal point go?
Before the 1.
1.1.
And so you could quickly do that in your head. 3 tens times 4 tens is 0.12 or 1200.
Do you have to put the 0 on it?
Yeah, you don't really have to, but that's the formal way of doing it.
Okay.
Yeah. You know, normally, formally in math, you always put it. In science, you always put it. Generally, you know, we don't put it on the street, in our homes, but you want to get the custom of putting the 0. You'll always see it on a math test or chemistry or science test. All right, the second one, we just multiply the numbers. What's 5 times 2?
10.
10. How many decimal place values are there?
5.
5. There's already 2 there, so you just need 3 zeros in the front of that 1 to make a total of 5. Does that make sense?
Yes.
Right? And that's how you can do stuff really quickly. And sometimes you see people do it so fast in their heads, and you're like, how in the world are they doing that? Well, now you can do it as well. 1 and 2 tenths times, you don't really need that 0, but we just keep it there just so that we remember. The 1 and 2 tenths times the 300s, just treat it like 12 times 3. 12 times 3 is 36. 3 decimal place values.
We have to add a 0?
Yes, you add a 0 there and put a decimal point in there. Right? You see, that's what makes the decimal system one of the easiest number systems in the world. And if you heard of the metric measurement system, we're going to get to that as well, because you're going to be mixing ratio questions with metric and all that. The metric system is based off of this concept. So if you understand this and practice this, knowing how to read it, it will really help you out in the future lessons that are coming. All right, this last one, remember, multiply the 6 and 7. What would that be?
42.
42. How many decimal points and all that stuff? What happened?
5. So add 3 zeros.
3 zeros in the front, right? With the decimal point. And that's how you multiply decimals. I was hoping to get to the dividing decimals today. But if you look through the rules, I think you guys can understand it on page, whatever page that was.
12.
12.
Yes, on page 12. See if you can do it. The basic rule, the rules are similar. If you want to see it, I could just go over the rules real fast. But I know it's late, so I don't want to go over the time. It's 8 o'clock. So if you want to practice reading that and trying it out, go ahead and do that. I will send a few things on Remind, so check it out. Some place value charts. I'm going to look for a ratio worksheet and some other stuff there. But you can try to do the problems. The division is pretty much the same. The simple rule, move the decimal point in the divisor, do the same in the dividend, and then just divide regularly. All right, if there's no other questions, enjoy your evening with your families, friends, and enjoy your weekend. I'll see you guys on Tuesday. And remember, if you have any questions, just send it on Remind, or you could ask right now. You're welcome, William.
Thank you.
Thank you.
Thank
Yes,
you, Mr.
enjoy your
Ray.
evening,
Thank
everyone.
you. Good night.
Good night, everybody.
Good night, everyone.
All right, everyone, have a great evening. Hopefully
Thank
see
you,
you
Mr. Ray.
Yes, you're welcome.
Yeah, thank you.
You're welcome.
Mr. Ray,
Yes.
this is Salvador.
Yes.
I was a little lost last week with the ratios and that stuff. In the beginning of the class, really helped a lot with all the questions they had.
That's
thank
good.
you for that. Yeah.
Yeah, and I saw you picked it up with the new stuff. So well done.
Yeah. Thank you. I kept on thinking what was wrong with me that day, and I just couldn't get it together.
Yeah, some days it could be fatigue. You know, our brains respond just like our muscles. You know, sometimes I don't know if you go to the gym, and you just can't lift the same thing you lifted last week, and you're just like, man, what's happening? It could be just fatigue sometimes. So never down yourself. You know, tomorrow's a new day, and today was that day, and you were excelling. So well done. Keep it up.
Thank you. See you Tuesday.
Yes, see you Tuesday. All right, you're welcome, Gennaro Marisol. All right, George, have a great evening.
Okay, bye.
Right, bye-bye.
Yeah.